from here, you start counting. This is what? This is what? These are the point at which two perpendicular lines meet. That angle is called angle 90. You draw it down. This is what? This makes it 180. You continue. This makes it what? 270. And what you are given there is what? 260. So it means that before it touches this edge here, your what? Your position will be what? C. Draw your broken line. So this one explains 270. I hope we are getting it. So that is just the graphical representation of what? Bearing. When you are doing questions based on bearing. So at this junction, we'll go to what? Question 9. Question 9. Question 9 says, what an object is, let's concentrate. An object moves in a straight line starting from rest. Now at this junction, you dare not just read it anyhow. You can't just read it and manufacture the answers offhand. What do? You graphically draw out the question, as in you interpret the question in a graph. Yeah, let's go. If the question given to you says an object moves in a straight line starting from rest. Now let's assume this point is the point of rest. Just indicating this is the point of rest of object X. Are we getting it? Now, if this is to be the point of X, of object X, now all you are looking for is the acceleration. Now, if the object is to move, let's redraw it. If this is your X, now your X moves towards this particular direction at what? 8 meters per second. Now, it now moves at a particular time 1.5 seconds. Are you getting it now? So if the first movement at which it moved was 8 meters per second in terms of velocity, it now moved a further 1.5 seconds. The first time was not really known, accelerated from here. Now it moved a further 1.5 seconds. Now I now say draw a sketch graph for a speed time graph. Find your acceleration. The acceleration for the first movement. Let's say this is our first movement. Let's name the first movement I, and let's name the second movement I2. 2. Roman figure 1 and Roman figure 2. If you look at that question, they now said find the acceleration in stage A. Your stage A, your velocity is given in what? 8 meters per second. Now that particular body started from rest. So then it gains a speed uniform for 2 seconds and attained a speed of what? 8 meters per second. Meaning that the first time at which he used to move was what? 2 seconds. He now moved further for 1.5 seconds. So total time of movement is what? 3 seconds. Are you getting it? So for we to actually now calculate the acceleration for stage I, what do? You deduce your what? The formula for acceleration. I gave it the other time. Acceleration is what? Your velocity per time. Velocity is measured in what? In meters per second, while your time is measured in seconds, which will give us what? The whole unit of velocity to be what? Meter per second squared. So from here now, what do? You analyze it based on your what? First parameter. Now the first parameter given there is what? 8, which is your velocity, 8 meters per second, and your time given is what? 2 seconds. So if you divide all through, you have your 4. So your acceleration here is what? 4 meters per second squared for stage I. For stage I. Now, if it now continues from where it stopped, it now continues at a further 1.5 seconds. At a further 1.5 seconds, what will be the what? Acceleration. What do? What you just do is, okay, it has now moved. It's accelerating here. It has not maintained a constant velocity. It's still accelerating. So you have to understand two phenomena here. What is it doing? Is it accelerating or has it exhibit constant? These are the point of what? Constant velocity. These are the point of what? Constant acceleration. So either of the two movement, you must be able to analyze the second what? Movement of what? The body. You have analyzed the first one by getting the first acceleration for the first stage of moving. That's from what? The resting point to your what? The first point if you deduct, if you recall, we said the object's first movement took 2 seconds. It now moved further towards 1.5 seconds. Now, the total distance moved is not 3 seconds, but what? 3.5. Sorry, pardon me for that. 3.5 seconds. Now, if we now proceed, if we want to calculate the acceleration for the second movement, what do? We will now say acceleration, Roman figure 2 now. What do? The total velocity moved is still your what? 8. Now, the time that will have been moved now is not going to be your 2 or what? 1.5 for addition of these two, which will give you what? 3.5 seconds. So if you proceed to calculate, what will you have? You have 8 over, or let's do it this way. Let's continue here. You have 8 meters per second all over your 3.5 seconds. So if you want to break this down, you have 8 all over, turn this to decimal, 35 over 10. Do you understand? 3.5 is equivalent to what? 35 over 10. So from there, you'll be able to have 8 times 10 all over what? 35. So you cut all through your 5 here 2, you have your 5 here 7. So you have 8 times 2, which is 16 over your what? 7. If you divide, you have 2.14. You have to 2.2 over 7 meters per second square. This will be your second acceleration reduced. So that is the second acceleration that will have been gotten, while the first acceleration is 4 meters per second. Now, let's go to the third question. The third question says that the total distance covered during stage A and B. The total distance covered during stage A and B. How do we solve that? We need to understand one thing here. Immediately a body is accelerating. It accelerated from here to here, maintaining a velocity of what? 8 meters per second. It still maintains that velocity of 8 meters per second to this second stage. Now, this first stage has to be analyzed. That is, it has a velocity and it has a time. Now, the distance covered can be measured in 2 ways. What do? A, distance covered. You need to draw the graphical representation of the first object. That is, your time is what? 2 seconds. And your what? Velocity is what? 8 meters per second. So your distance can be calculated with the what? Area of this triangle, which is what? Our base times height. Now, our base here can be given as what? 2. While your height here can be given as what? 8. So 2 divided by 8 will give you what? 4. So 4 times 2 will give you what? 8 meters. So that's the distance covered by that body for what? Stage I. Now for your stage II, this is for stage I. Now for your stage II, that's your stage 2. Your distance can be given as base what? Times height. Now at this point, the base is now 3.5 for II. So for II now, we now have half times base, which is now 3.5, times your what? Height, which is still your 8. So if you use your 2 to cut it, you have 4. So 4 times this, you have 4 times 0.5. You have your 3.5 times 4. What do? This is 20, this is 12, and this is what? 14. So you have your 14 meters. So those are the what? Distances covered for by both stage 1 and stage 2. So that with that, we are able to what? Resolve question 9.